Good afternoon, everybody. We're getting ready to now move into operations with integers and rationals. Integer addition is pretty intuitive. You've been doing positive integer addition for a very long time, so 3 plus 4 is 7. When the numbers are both negative, it's pretty intuitive as well. In other words, if the football team lost 3 yards and lost 2 more yards, they're down a total of 5 yards. And there's a little song that helps us to remember what to do when we are adding integers. And it's to the tune of Row, Row, Row Your Boat. And this class will show you exactly what it is.
Same signs, add and keep, different signs subtract. Keep the sign a bigger number, then you'll be exact. Same signs, add and keep, different signs subtract. Keep the sign a bigger number, then you'll be exact. Same signs, add and keep, different signs subtract. Keep the sign a bigger number, then you'll be exact. Olé!
Very cute little song. So when you're confused, you can just sing yourself that little integer song about what to do. When we're adding opposite signs, we subtract them and take the sign of the bigger number. So for instance, if I had negative 5 plus 2, same signs? No. Different signs subtract, take the sign of the higher number, then you'll be exact. So different signs, I'm going to subtract 5 and 2 and get 3, but it's negative because the 5 has a greater absolute value. Okay, so I think you kind of get this. This is like, oh, the football team was down 5 yards and they gained 2, they're still down 3. Right? Now, integer subtraction is a little bit more confusing, so I'm going to show you a little demo here of how we actually rationalize what to do with integer subtraction. If we look at this little oval here, it says click and drag plus chips to represent the first term, so I have 5 pluses. Now I'm supposed to take out of my oval 6 negatives. Well, I don't have any negative chips in there to remove. It's very difficult to take out 6 red chips when there are no red chips. So what do we do? It says click continue. Well, what we're going to do is add enough 1 plus 1 minus chips representing 0. I'm going to add 6 zeros so that in fact now I can take out 6 negative chips. 1, 2, 3, 4, 5, 6. And what am I left with? 11. Okay, let's check that. Yes, let's try another problem. Okay, I'm starting with negative 2 and I want to subtract positive 2. Well, I have no positives to take out. Can't take out 2 black positive chips. So I'm going to need to put in 2 zeros basically. And when I take out those 2 positive chips, what am I left with? 4 negative chips. So this answer is negative 4. We'll do one more together. I'm starting with negative 1 and I want to take out 6 positive chips. I don't have 6 positive chips, so I have to put in 6 zeros. Now I can take out 6 positive chips, and what am I left with when I take out the 6 positive chips? I'm left with 7 negative chips. So what does this tell us? We have to really think about that. So let's look at our rules that we have for adding and subtracting integers and rationals. First, the first thing you're going to want to do is change any double operations to one operation. Example, let's say that I had negative 2 minus negative 8. It has this double operator here. So I want to change that to a super positive. A double negative is known as a super positive. It's like if you say, I ain't got no lunch. Well, if you say, I ain't got no lunch, that means you don't have no lunch, which means you have a lunch. So that's a positive. The second one says negative 2 plus negative 8. So again, I have this double sign, but plussing a minus is the same as just a minus. So I don't want these double operations. Then we use the thought process that we are actually combining numbers that have signs attached to them. So this is like combining negative 2 with positive 8. Different signs subtract. So I'm going to subtract 2 from 8 and take the sign of the higher number, 8, and I'm going to get 6. 6. Example 2, I'm combining -2 with -8. Same signs, add and keep, so that's going to give me -10. Let's try a few examples together and then I'll let you work on your own. If you're all set and you know what I'm doing here, go ahead and work on this sheet on your own. Alright, so the first thing I'm going to do is I'm going to eliminate any double signs. Well, this, super positive. So I have -6 plus 15. I'm combining a -6 with a 15. Well, different signs subtract. 15 from 6 gives me 9. Take the sign of the higher number. 9 is my final answer. Number 2, 8 minus 19, there's no double signs. So I'm combining a +8 with a -19. Different signs subtract. So I'm going to subtract 8 from 19, giving me 11. Take the sign of the higher number. It's going to be negative. 21 minus -7 is a super positive, and that's old-fashioned addition. So you should be pretty good. Make sure to go through and change any double signs before you do the work. Remembering, if I look at number 6, that when I have plus and negative, that's the same as just a minus. So this is -32 minus 41, which is same signs, add and keep. So I just add these two up and I get -73. Final answer. Go ahead and work through question 15. Pause, come back and check your answers. Okie dokie, here we go. And you can notice that I did change those double signs where appropriate, and you should do so as well. So if you have any questions on those, please highlight or circle them and we can discuss them tomorrow. I'm going to move on to add or subtract rationals. Well, let's think about this. Adding and subtracting rational numbers. Well, rational numbers are the same as any other number. They have to follow the same rules. So I have to combine two sets of rules, my adding and subtracting integers with my adding and subtracting decimals and fractions. So I have to keep two things in mind. I have to know which number's bigger. I have to know if I'm adding or subtracting, okay? And sometimes it can get ugly if you have to rename and then they're opposites and opposite signs, but we can do it. So let's just take a look at the first one. -1/2 plus 3/4. Well, different signs subtract. What's bigger? 3/4 is bigger. What's my answer? Well, I happen to know this intuitively, but if I had to get common denominators, I could still do it, and I would get 1/4. The next one, I have to change this to a super positive, and I get -3/5 plus 6/8. So here I am going to want to change them and make a common denominator. This becomes -24 over 40, and this becomes +30 over 40. Different signs subtract, so I'm going to subtract 24 from 30, giving me 6, and I am going to keep my common denominator, and the 30/40th is bigger, so I'm going to keep it positive, but I do have to always simplify. I cannot give an unsimplified answer pretty much ever. There are exceptions, but not likely. The next one is a decimal. So I have -4.6 minus 2.35. Same signs, add and keep. Pretty straightforward. Could probably do it in your head. And you should get -6.95. Let's go on to the next page. There are 3 at the top. You can try those on your own and come back and check your answers. Okay, so the first one, these parentheses don't really mean anything other than they're holding the negative to the 9.33, so I don't really care. That's still a super positive, and I get 2 43 thousandths. And the next one, same signs, add and keep, so that's easy, -18.66. And the next one, now kind of interesting here, and I'm going to talk about properties in our next unit, but I don't want to have to do subtraction twice or anything. I like to make these easy. The commutative property of addition says I can combine things in different order. So I have a -10.142 and a -8.05. I added those together first and got 18.192, and then I only had to do one subtraction, and my final answer was -11.492. So if you have questions about that particular strategy, we can go over that tomorrow. It's a very helpful strategy. What I'd like you to do next is just complete this page and come back and check with me. Okay, I kind of cheated you out here because I'm not going to actually go through 26 through 29. We are going to discuss those as a class tomorrow. And so all you need to do is try your best on those and we will discuss them tomorrow. We are also going to work a lot more with rationals, adding and subtracting them. Have a wonderful night. I'll see you all tomorrow.